Just take a second and look at the buildings around you. I mean, really look. The concrete, the steel, it's all so impressive, right? But what if I told you it all comes with a hidden environmental price tag that is just massive? We're about to dive into something that could totally flip the script on how we build our entire world.
Okay, let's start with a big number. Globally, the building sector is a climate giant. It's responsible for a whopping 39% of all carbon dioxide emissions. And that's not just the power we use inside them, that's the materials we use to build them in the first place.
Now, if we zoom in on just one material, the picture gets even clearer. Concrete. It's everywhere, the most common building material on Earth. And all by itself, it accounts for 11% of global CO2 emissions. Think about that. The very foundation of our modern world is a huge part of the problem.
So yeah, the bottom line is pretty simple. Our buildings have a colossal carbon footprint. And as our cities keep growing, this problem is only going to get worse, unless, of course, we find a radically new way of doing things.
All right, so here's a roadmap. First, we'll dig a little deeper into the problem with concrete. Then, we're going to meet two of nature's tiniest, most powerful builders. We'll see how one team is literally 3D printing living bricks with bacteria and how another is growing materials from fungus. And finally, we'll ask the big question, what does this all mean for the future?
So let's kick things off with concrete's massive footprint. We all know it's strong, it's durable, it gets the job done, but as we just saw, its popularity comes at a really, really high environmental cost.
Which, leads us to the billion-dollar question. How can we possibly build better? If the materials we rely on are so damaging, where do we even begin to look for an alternative? Well, it turns out the answer might be hiding in plain sight, just on a microscopic level.
Instead of manufacturing stuff with insane amounts of heat and pressure, some scientists are asking a different question. What if we could grow our materials? And to do that, they're turning to two of Earth's oldest and most clever life forms for some inspiration.
Okay, first up, meet cyanobacteria. These little guys are incredible. They've been around for about 2.8 billion years. They actually helped create the oxygen in our atmosphere. But what's super important for us is that they can produce something called calcium carbonate, which is basically a natural biocement. They literally build with. And our second tiny builder is Mycelium. Now this is the root-like network of a fungus. You can think of it like a super strong, natural glue that assembles itself. As it grows, it weaves through stuff like sawdust or straw and binds it all together into a solid, lightweight material. So it's one thing to know these microbes exist, but how do we actually harness them? Let's start with a really high-tech approach. Researchers are combining the incredible precision of 3D printing with the natural building power of cyanobacteria to create something they call living building materials.
Here's how it works, and it's pretty wild. First, they cook up a bio-ink by mixing the cyanobacteria with sand and a hydrogel. Then, a 3D printer squirts this ink out into a scaffold shape like a little brick. After it's printed, they put the scaffold in a special solution that basically tells the bacteria, okay, it's time to get to work. And that's when they start producing that natural cement, which makes the whole structure hard and strong.
So, did it actually work? Oh yeah, the results were pretty amazing. When the researchers compared the scaffolds that had the living bacteria to identical ones without them, the living materials were way, way stronger. The bacteria weren't just sitting there, they were actively making the material tougher. How much stronger are we talking? Get this. After the whole process was done, the living material with the cyanobacteria was a whopping 6.6 times stronger than the sample that didn't have any bacteria. That right there is the power of biocementation in action. All right, so that was the high-tech, laser-focused approach. Now for our second solution, which is much more low-tech, but honestly could be just as revolutionary. Instead of precise printing, this is all about growing materials from mycelium, using stuff we'd normally throw away, like agricultural waste.
And the possibilities are just so cool and versatile. I mean, companies are already using mycelium to make sustainable packaging that can completely replace that awful styrofoam. You grow it, you use it, and then it just biodegrades. No waste. But it totally doesn't stop there. Because it's so light and you can grow it into pretty much any shape you want, designers are making furniture out of it. Chairs, tables, even lampshades. It really shows you this stuff can go way beyond just simple blocks. But how does it really stack up against the materials we use every day? Let's just look at the numbers. Mycelium blocks are incredibly lightweight, way less dense than cement. They're fully degradable, so you get this perfect circular economy. And the cost?
while the cost is maybe the most shocking difference of all.
A cubic meter of mycelium block costs around $19 to produce. The same amount of cement block? Over $940. Yeah. Some research suggests these biomaterials can be up to 80 times cheaper. I mean, that is an absolute game changer.
So, what does this all mean when you put it together? We could be looking at the dawn of a whole new era in material science. By working with bacteria and fungi, we have this incredible potential to create a truly circular economy, where we turn our waste into valuable, sustainable building materials.
And this one quote, for me, really just nails the whole idea. It's a fundamental shift in how we think. We're moving from an energy-guzzling manufacturing mindset to a biological one. We're not just making things anymore, we're collaborating with nature to grow them.
It's such a powerful idea, right? And it leaves us with this final, fascinating question to chew on. With technologies like these, are we on the verge of a future where our buildings, our furniture, and maybe even our cities aren't just built, but are actually grown?